All right, so let's talk about the next data type. We have indexed arrays. Do you know what's coming next? We have associative arrays. Associative arrays. Let me make sure I spell that right. Associative arrays are sort of like, think of like, I think JavaScript has objects, Rust has hash maps. What else do they have? Python has dictionaries. It's like a key value. It's just an array, but instead of having a number, it's not indexed based on a number. It has an arbitrary string as the key. So we can make one here. Let me do this so I don't forget. So remember how we could use declare -a, but we didn't have to? When you make an associative array, you do have to use the syntax capital A. So we have to do a -A here, and now we can make our own array. So let's call it ARR. Now here's the fun thing. Associative arrays are relatively new in Bash. And when I say new, I mean like they're 15 years old, but they are in Bash 4.0 and above. So if you're thinking, I want my script to work on an older system, I should check the Bash version, right? No. You should not do version detection, you should do feature detection. The cool thing is, this declare command, you can check the exit code of. So if I run this script now, we can see that it exited 0. I was successfully able to make an associative array. You could check this and you could exit if something went wrong. So you are free to write code like this. If not declare -a an array, then echo, uh-oh, I couldn't make an associative array. Let's write that to standard error. Let's exit with 1. Let's call phi here. Otherwise, if we were here, then we were able to make the associative array. So you can write code like that, kind of defensive. If you know what kind of version of Bash you're targeting, you probably don't need to do this. But just an FYI, you could totally write it like that, and that's how you would check it. Don't check the Bash version, just check for the features that are there. I'm going to get rid of that just because this is more of a learning exercise. So let's see what we have here. Now that we have this, we can do some magic here. We could say foo equals 1. We can copy this down. Bar equals that. Baz equals this. And we could do 2 and 3. So what happens now? Well, we can go ahead and we can echo that and we can see what happens. You ready for this? Nothing. We got nothing out of it, okay? We actually have to key into this. So let's go ahead and key into this. How do you think we key into this? Well, it's exactly how you key into the other style of array. You use the open and close square brackets, and you put the literal key that you want to get out of it. So you can do this, foo, bar, baz. So if this works, we should print 1, 2, and 3, correct? There we go. Hey, that's awesome. That's great. You can quote these if you want. You don't have to, but you can quote them. They'll work exactly the same. I choose to leave them out if I'm putting the string in there myself, but just an FYI, you definitely can quote them. If we were to put something here that's not valid, if we were to put fake here, we will get an empty string. Same thing as indexing into an array with a bad number. We're indexing it with a bad value, so we just get effectively an empty string. Now, similar to this, we can do what we did last time, which is if we want to loop the array or we want to see what elements are in it, we can try the star notation, we can try the @ notation. They'll look pretty much the same when we run it. We can see 1, 2, 3, 1, 2, 3. They both loop over the values, not the keys. They loop over the values. So if we wanted to loop over the keys, I'm going to go ahead and just get rid of this @ notation because we want to stringify the value for this notation. That's why we're using the star. Star is for when you want to stringify it. If we want to loop over the keys, we can put an exclamation mark. An exclamation mark, this is the indirect operator or indirection operator. You'll see it in other variables. I'll talk about this later. But for arrays, this means act on the keys and not the values. So if we run this again, we can see that we get foo, bar, and baz. We get the keys out of it. So that's what the exclamation mark does there. This is useful because if we were to do a for loop, we could do for key in and then change this to the @ sign because we want to quote it and we want the @ signs. And we do want the exclamation mark there because we want the keys. We can do done. We can echo got key. So let's go ahead and run this, and we should have got foo, got bar, got baz. Hey, that makes sense. Let's go ahead and clean up some of this stuff. We don't need to keep seeing this. So now, how do we get the value out of it? Very simple. We can do value equals, and then we have to index into that array. The array is called ARR, and the key we are using is just called key. That's it. Now here's the thing. If this were a numeric array, this would be totally fine. But with this syntax, it thinks we're looking for a literal key named KEY. So if I were to run this, you can see that got foo, got bar, got baz. Oh, I didn't print anything. Yeah, so let's go ahead and got key equals value. So let's print this. So we have got key equals value. We're trying to index into this. And now we have got foo equals nothing, bar equals nothing, baz equals nothing. That's not good. It's trying to key into a literal string there. So when you're using associative arrays, you do need that $sign there. We need to expand what's in the key variable here. And then when we run this, we will see got foo equals 1, bar equals 2, and baz equals 3. So I'll give you a little moment to take this in. But this is how you would loop over an associative array in Bash. They're surprisingly useful to have this data structure under your belt.